So here's a normal distribution example. So we have a large group of physics students took a final exam and had a mean of 73 and a standard deviation of 10. If the grades were normally distributed, what is the probability that someone scored higher than an 80? Okay, so we have a couple things. We know that our X value, or here are all of the grades for the final exam, is normally distributed with a mean mu of 73 and a standard deviation sigma of 10. Okay, so here what we want to find is that the probability that someone scored higher than an 80. Okay, so if I were to graph this, we know that our mean here is 73. And we want to figure out the probability that someone scored higher than an 80. So we know that 80 is around here. Okay, so we want to find all of this area. That's what we want to figure out. Okay, so because we know that it's normal, we know that we have to use Normalcdf. So we will write Normalcdf. My lower bound in this case, so where the area starts, it's at 80. And then my upper bound goes all the way to positive infinity. So we just would write a really, really big number. Okay, so that's my upper bound. That's my lower bound. This is my upper bound. My mean in this case is 73 because that was given to me. And my standard deviation sigma is just 10. Okay, so all I have to do is just put this in my calculator. So whatever calculator you have, go ahead and put it in there. I'm going to use the graphing calculator right here since I have the emulator. So I'm going to have second vars, going to go down to Normalcdf. My lower bound is already going to be 80. My upper bound is going to be a really, really large number. Okay, then my mean is 73 and my standard deviation is going to be 10. Okay, so then I'm going to press enter. And I'm going to get up roughly about 0.242. Okay, so it's going to be 0.242 because we want it rounded to 3 decimal places. Okay, so roughly about 24% of them scored above an 80. Okay, all right, so now let's go to our next problem. What is the probability that someone scored less than a 63? Okay, so we still know that this is going to be 73. And that's our mean. Less than 63, 63 is around here. Okay, so we want to figure out what that area is. Okay, so now I flipped it a little bit because now we're still using Normalcdf. The only thing is that now our lower bound is not going to be 63. Now our area extends further over to the negative side, which is like negative infinity. So that's actually where my area starts, from a negative small number. So let's just say negative really, really large number. Then it ends at 63. So that's my lower bound, that's my upper bound. My mean is still 73, and then my standard deviation is 10. Okay, and what does this give me? So I'm gonna go back, second vars. My lower bound is now minus a really, really large number, all the way to 63. Standard deviation and mean stay the same. So I'm going to get 1587, or around 159. Okay, so 159. Okay, that is my answer for that one. Then we want to figure out what percent. So notice that this problem, we're not talking about percentages. We're not talking about probability. So what percent of students pass the test? Round to 3 decimal places. Okay, so this is 73. Okay. Okay, so we're going to assume that this is out of 100 points. Okay, so we want to figure out, okay, well, what percent pass the test? So in order for you to pass, you have to score a 70 and above. Okay, so what percent of these pass this? Okay, so this is going to be 70. Okay, and it's going to be all the way above. So everything above a 70. All right, so what would this be? Okay, so we're going to go ahead and use Normalcdf again. Okay, so Normalcdf. So my lower bound is going to be a 70. My upper bound is going to be all the way to infinity, which is just going to be a really, really big number. My mean is still 73, and my standard deviation is 10. Okay, so I'm going to press second vars. Gonna go down to normal CDF. Okay, we're gonna say that my lower bound is gonna be 70. My upper bound is gonna be a large number. And then everything stays the same. Okay, and what I'm gonna get 0.68. 0.618. Okay. Now this is not quite the answer because we're looking for the percentage of students who pass. So this is going to be 61.8%. Okay, so roughly around 61.8% pass this exam. Okay. All right, so now this problem, what percent of students did not pass the test? Let me give you a little more information on this because this might be a little bit misleading. Let's just say that something that's not passing will be a 69.9. That would not be passing the test, okay? Just because, I mean, it can be 69.999, or maybe people can think that it's just going to be 69. So let me just say that I give you this additional information, 69.9. Okay, so what percent of students did not pass the test? So we know that the mean is still 73. The people who did not pass the test would be people who scored a 69.9 and below. So everything below it, that's the people that did not pass. Okay, so this is going to be normal CDF. Okay, we're going to start from the very, very low. So negative 1 million, or a really, really big negative number, all the way to 69.9. Okay, mean is 73, standard deviation is 10. Okay, so what are we going to get? So second vars, normal CDF. Okay, so a really, really small number all the way to 69.9. Okay, that hasn't changed. So this is going to be 0.378, I guess. Okay, 0.378. Okay, so roughly around 37.8%. Okay. Okay, now notice that there's another way that you could have done this problem. We already know how many people pass the test. Okay, we know that 61.8 passed the test. Something else that we could have done to make it a little bit more accurate. So more accurate would have been to take 1 and subtract it by 0.618. Because if I know that these amounts pass the test, I can just do 1 minus 0.618, and what I get is 0.382. So there's two actual answers. This one's more accurate because, and the reason why these two numbers are different is because there's still some numbers that are between 69.9 and 70. So there's still a couple of numbers. So we are a little bit off here, but I will accept these two answers. This one's a lot more accurate though. Okay, now our last problem, what grade was the 25th percentile, round to 1 decimal. Okay, so we know that 25% is below the 25th percentile. So this is basically what I'm asking. So I want to know what grade, okay, so I don't know what grade it was, is a 25th percentile, which basically means that right below it, this area is all 25%. Okay, so 0.25. So we want to figure out, okay, so what grade, or 25% of the students that scored below this grade are down here. What is this grade? Okay, so we don't want to use normal CDF like we were using. This time, since I'm asking you for a percentile, I want to use the inverse normal. Okay, so inverse norm. And what we want to figure out is, okay, what is the area to the left? So the area to the left in this case will be 0.25. My mean hasn't changed. It's still 73. And then my standard deviation is still 10. Okay, so that's what we are using for this type of problem. So we're using the inverse normal. Now I give you the probability, I give you the area, I want to figure out what the x value is. Okay, and that's just going to be, so let me go under second vars one more time. Whoops. Second vars, gonna go down to inverse normal. Okay, so here it tells me what is the area. So that's just gonna be 0.25. What is the mean? This is gonna be 73. And then what is my standard deviation? That's just gonna be 10. Okay, I'm gonna press enter, and the answer is going to be roughly around 62.3. So I'm sorry, 66.3. Okay, so a score of 66.3 is the 25th percentile, which basically means that 25% of students scored below a 66.3. Okay,